And good afternoon, everyone. Thanks for joining us. My name again is Zach with ATS. I am the ATS accounts manager or market development manager, working with engineers, architects, design build contractors, interior designers, even some of the manufacturer reps out there, and assisting them in utilizing the various spec tools all across North America. If you are unfamiliar with ATS, essentially we're a software program that specializes in product selection tools for the plumbing and architectural industry. One of our big partners in this space is, we're partnered with about 40 different manufacturers, but one of our biggest and supporting probably the most categories in our spec tool is the Watts Water Group. From everything from all the backflow and drains into all the new products that you guys keep getting, as you know, Watts seems to be getting new and new manufacturers every couple of years. And one of the great ones has been, getting into leak detection, getting to mixing, and all sorts of new products in that side. So that's kind of what we're going to focus on today. And a couple of pieces of housekeeping before we dive in. This, of course, like all of our other webinars, is going to be recorded at the end of the presentation. I'll show you how you can find the recording, and also how you can use the Spec Hub system or the ATS spec tool to find exactly what we're discussing today and show you how you configure these products on the spec tools. We'll also be able to send out your ASPE accredited certifications. I think the process should be out tomorrow. Or no, because usually we do it on a Wednesday. So usually we have it done by Friday. So we'll probably have to give Natalia the weekend to get these out. But thanks for joining us on a Friday, everyone. This is an exciting presentation. We're excited to have Dave here from the WattsWorks team. Like I said, we're going to dive into a bit of a newer category that I think is really interesting in how people are addressing some of these new challenges that are coming up as building design changes. I guess without any further ado, Dave, I'll pass it over to you. Thanks for joining us today.
Hey, Zach. Hey, thanks for having me, everyone. I appreciate you spending your lunch with us here. I'm Dave Stearns. I'm Business Development Manager for Mixing for the East Coast at Watts. And today the presentation is solving hot water control and cross-flow challenges. As Zach mentioned, this is an accredited presentation for ASPE CEU. If you're a CPD or a CPDT, you'll be getting 0.1 credits for this. If you're a PE, you want to check with your state to make sure this is acceptable for a renewal. Course objectives, I'll go through this. I think the way I like talking about this is like, look, our goal for designing a hot water distribution delivery system in potable water is, we want fast, efficient hot water delivery to our clients and our customers or occupants in those buildings. If you end up having, and again, our part of that is keeping the hot water hot and the cold water cold. If we don't do that, or if one stream of hot goes into cold or cold goes into hot, that's where we run into problems. Now, I think anyone that's been involved with trying to find out where that cross flow is coming from the hot to cold or cold into hot, that becomes incredibly, frustrating and challenging. I was just on a call, 15 minutes ago, and that was kind of the topic. But anyways, so we'll kind of talk about identifying those. We'll kind of look at some of the technology that's been around for a long period of time. I think we're used to using it. It's tried and true. But then what I'm going to do is flip gears and kind of talk about some of the newer technology that's available to us. And I'll give you guys examples of like where it can be used to help understand, well, one, just how is my system operating? But two, if I happen to have a bad situation where things are flowing where they shouldn't be, how we can use that to identify it. So that's really what we're looking at. We'll talk about some improvements that have been made to some point-of-use mixing. This is really exciting stuff. But ultimately, when we start looking at some of this newer technology, ultimately what we're going to have is just, a system that's more reliable, more efficient, and then ultimately more sustainable. That's really what we're going to be talking about today. So I'll start talking about a little bit of the challenges. We'll go with that. and really with this, we have, as we design our systems, we have competing objectives, right? So with that, I think what I mentioned is obviously natural resources. Those are one of those things that are more and more interested in conserving these days. So I think one, water, and two, energy. But when we think about that in context of a plumbing system, and if we start conserving that, then ultimately what we could do is create stagnant conditions. And then if we're not using energy, then obviously lower temperatures, that becomes an ideal situation for Legionnaire's disease, right? So that's one thing we have to be concerned about. So now, okay, let's jack the water temperatures up and use temperature as a mechanism to mitigate that. But then our concern then becomes scalding. So there's that kind of fine line that we have to kind of look at between those two. So I'll give you a little background on both, and we'll get through this. As we're going through this presentation, we'll be talking about some of the ASSC standards. When you have point of use protection, a lot of that testing in those standards is around 120. And if you look over on the left-hand side of your screen, you'll kind of see where that comes about, right? So at 116 degrees, that's pain threshold. Ouch, it's starting to hurt. But it's going to take 35 minutes for you to get to that first degree burn. Now, if you look 6 degrees higher at 122, within a minute, you're going to get a first degree burn. So you see that threshold of temperature that it becomes very sensitive, right? And that's where we want to protect our occupants from. So a lot of times when I talk to engineers, it's like, Dave, we put mixing valves in. We never would ever have these issues in our buildings, right? So we think. This is kind of an interesting, I'm going to call it study. So, I travel on the East Coast, stay in a lot of hotels. And the folks from Powers, basically what they did was they started taking temperatures at the lab and the showers and annotating those temperatures, right? Basically, what you'll find, I'll summarize this, about 55% of the rooms had temperatures at or above 125 degrees. So if we think about, our previous slide there, that's pretty toasty water. What is more interesting is that about 10% of them had temperatures at or above 140 degrees. So that's quite hot. Recently, separate from this, but recently I was probably 2 weeks ago, I was at a facility, mechanical mixing valve on place, and ultimately some people were fooling around with the valve. He started showing me that there's temperatures leaving the shower at 190 degrees. So you kind of see, yeah, I know. I'm like, whoa. So anyways, good candidate for some mixing valves, yes. Anyways, let's go into the other obstacle that we might face is Legionella. This is, and again, popular topic, a lot of information that's been out there. I think there's a lot of seminars on this, but just a little background for the audience, if it is new to you. The bacteria, Legionella is a bacteria found naturally in the environment, typically in bodies of water or moist soil. It's at levels that are really not harmful to humans. But what happens is if we bring that into a man-made water system at the right temperatures and in stagnant conditions, that's where it starts to amplify. Now, I could have a glass of water laced with this, and I could drink it, have no issues, right? It's a respiratory disease, so it has to be aerosolized, and I breathe that in. If you start thinking about this a little bit more, the other things that you have to really be concerned about is people that are at risk. So at-risk population is, you got folks over 50, smokers, anyone that has chronic lung disease, or a compromised immune system. So if you start thinking about this for a second, most likely that at-risk population will be more long-term care facilities or, hospitals, things like that. So if I start looking at this is kind of another interesting fact. The CDC actually looked at all the outbreaks between 2000 and 2014, and they basically said, when I saw this, I really thought, oh yeah, those long-term healthcare facilities or hospitals are going to be basically where the outbreaks are. It turns out hotels are the vast majority of it. The other interesting thing is I follow this topic, so I kind of geek out about it a little bit more than most. But when it pops up in the news, what is that source? And a lot of times, cooling towers seem to be one of the things I would have thought would be the main culprit. It turns out here it's potable water was really where these outbreaks were. So anyways, near and dear to our hearts, and obviously we'll come back to this topic here today. Why did they have these outbreaks? It was one of these four reasons or a combination of it. So when we talk about a process failure, I'll talk a little bit about this. There was no water management plan in place. So we'll kind of look at some of the documents or literature that's available for that. A human error where someone was making changes, things that they shouldn't have. And if you think about this, and I think talked about that, scenario where the person was fooling around with mixing valves and sending out 190 degree water. That's, again, not that would cause Legionella, but Legionnaire's disease. But anyways, people messing with things they shouldn't be. Equipment not operating properly, that would be one thing. And then unmanaged external changes like a water main break or something of that nature. So those are things that, keep in the back of your mind. I'll come back to that a little bit here and later. I mentioned there's some documents that could be used for coming up with these risk management plans or coming up with strategies to mitigate Legionella. ASHRAE 188 is a great document that's referenced in the industry. And then that tells you what to do. So it kind of goes through the 7 steps associated with the risk management plan. So that's what to do. How to do it is guideline 12, right? That kind of gets into the nuts and bolts and like, hey, you know what? We can use temperature to help mitigate it, for example. Where this became quite popular is there was a CMS, Center for Medicare Medicaid, said, hey, you know what? Any healthcare facility using Medicare Medicaid has to have a risk management plan in place. So that was one of those documents that came out and was very useful. For what it's worth, if you haven't read it, the CDC has a toolkit. I call it a Cliff Note version. It's a great document. If you're doing plumbing designs and have trouble going to sleep at night, that's a good read, right? Anyways, today, obviously, I'm going to be talking about using temperature for controlling that or mitigating it. That's really what we're going to be talking about today. But I just want to make it, obviously, there's other technologies out there that can be used and are available and should be investigated if that's one of the goals of your project, to mitigate that risk. The other thing, obviously, when we're talking about using hot water or water temperature to mitigate the risk, the one thing that becomes very clear is understanding crossflow and crossflow issues. Because again, if I'm keeping one side hot, one side cold, and those two things start intermingling where they're not intended to, or you think they are, separated, right? Think about 2 kids break up a fight, right? This is what we want to do with hot and cold water. But if all of a sudden they start intermingling, and we don't intend for that to happen, understanding where that happens and understanding equipment is really critical. 1, for occupant satisfaction, but 2, obviously the safety if we're trying to mitigate that risk of Legionella. Here's a quick example. This is from the CDC toolkit, and just real briefly, they really kind of talk about, okay, here's the 7 steps associated with a risk management plan. First, obviously, you're going to assess the building. Does this need a risk management plan? That's 1. 2 is like, okay, if it does, then a team gets put together. Part of that team basically maps out the water as it comes into the building to when it leaves, and that's what we're showing over here. Then you identify all the risks associated with that. So, for example, we're looking at the heating or hot water system. So, hey, how am I monitoring that temperature? In the distribution, am I monitoring the temperature when it returns? And I want to monitor it for low temperatures, as an example. I want to monitor it for stagnation. So ultimately, you start going through, what am I monitoring? And then how often, if it goes outside of these parameters, what do we do then? And by all means, like if we test and then there's some sort of Legionella detected, what's their response then, and so forth. And it's just an iterative process. So you can see over here, for today's presentation, keep in mind, it is the whole network or distribution system. I'm just talking about the hot water distribution at this point. So there's far more to it than what I'm talking about today. When we do talk about the distribution temperatures, guideline 12 says that distribution should be at or above 120. The VA directive talks about at or above 124, just for reference. So a couple things just to keep in mind. So now we'll start talking about technologies available to us. A couple things, I'm going to kind of talk about some of the traditional technologies used in both mixing and balancing, right? So I think in these scenarios, all scenarios, maintaining a good distribution temperature out there and then balancing it so that it gets out to the entire structure of the building fast and efficiently is what we want to do. If I look over here, when we look at mechanical valves, those actuators, they evolved over time, but ultimately paraffin wax was pretty much widely used in the industry today for mixing valves. Point-of-use mixing valves, that's commonly used technology. It's very fast, reliable, and stood the test of time. Early 2000, digital mixing valves came onto the scene, and with these, it was pretty cool. They were racked, very sensor rich, and you could tie them into a building management system, right? And so hospitals, high-end hotels loved them. Contractors loved them because it solved a lot of the problems on the mechanical side. And I'll talk about that in a minute. But I guess, fast forward, people liked it. So they came up with smaller versions, right? Something and then less sensors. So it's a little more economical. and it could be used in other buildings other than, that high end, those buildings with the budget. So when you start looking at that and you have, a decade or more of just experience, when you take that and use that and throw that into the next generation, that's really cool because all those lessons learned over 10 years or more were then incorporated into this next generation that we'll talk about. One thing, when we start talking about distribution, and then we obviously want to dial in that temperature before we send it out. So these are some just, rules to live by for, traditional or advanced master mixing valves, ASSC 1017. Having a pressure differential between the hot and cold within 20%. Field install these according to the manufacturer diagram. That's probably one of the things I look at a lot of mixing valves, go in and we install a lot. That's probably the culprit of why a lot of them are, I'm going to say air quote, not working, right? So that's one of the things, and I'll talk about that briefly here. Sizing these, again, you don't want to size them per line size, right? That's one of the, another thing I see. If you oversize the valve, that element will cycle a lot, and then you'll end up having to rebuild it quite frequently. So a lot of manufacturers have tools on their websites where you can size this, and you'll notice that will actually size it for your design flow rates. And then you have your minimum flow rates as well. And typically I look at like recirc flows. So anyways, and then last but not least, depending on the water quality, right? Every manufacturer says, hey, you should really do this to maintain your valve. If you have tough water conditions, then obviously you might have to do that more frequently. From an installation perspective, this just kind of, I like going through this. Again, this is common for a mechanical valve, more traditional valve. And if you look at this, you got to think about it in two conditions, design flow. So I have hot and cold coming in, and I got a bunch of fixtures, it knocks the water temperature down. So the opposite situation happens if I'm like, I have no fixtures flowing. I have to get cooler and hotter water back here. So this recirc pump takes this recirc flow, and we put some of that colder water into the cold, and the rest goes back to the water heater and gets pushed out into the hot side. So that's really how that's going to operate. Now, there's a balancing valve here, right? So what that does is forces some of this, most of the return water back to the cold side. If you don't do that, then what happens is, or if it doesn't get done, I should say, the hot water is going to get pushed through this hot side, and the seats on these valves don't have positive shutoff, so you're going to have temperature creep overnight with low usage. You notice the check valves, obviously, where hot and cold collide, right? We want to keep those things separate, so that's its job. But this is kind of one of those things, and then temperature pressure gauges, so we can kind of look at what's happening in and around the valve. That's important. That's kind of just a common, normal, good practice. Again, so that's what right looks like. When we look at more limited traditional valves, most manufacturers have, standard mixing valve lineup of different sizes, 3/4 up to 2 inch. There's a standard rate of flow. Then they might have another kind of category of valve that, standard rate of flow, but down to lower flows, and that would be a high-low valve. When you start having projects that have flow ranges outside of that, then you put two of them together. So you can kind of see over on the left-hand side, there's a little guy here and a bigger one. And in between is this PRV, pressure reducing valve. So that's kind of a staging device. So a lot of little flow goes through this valve. As you get more flow and the pressure starts to increase, the second one goes online. Over here, you might need more than two. That's where there's 4. Most manufacturers have these rack systems. So all that piping I talked about in the previous slide, you can kind of see that's really taken care of in these rack systems. And then last but not least, you have some digital valves that we'll get into. And that really helps solve a lot of the issues that people run into with mechanical valves. For point H mixing, ASSC 1070 mixing valves, this is very standard in the industry. These are a 4-port valve, H pattern. So you have your hot and cold coming in. It's very compact. You have the mix coming out and then the cold going straight through. If they have the sensor faucet, you can cap that. You have a 3-port valve. Those are, again, very popular in the industry. You might have a multi-listed valve, i.e. 1070 and 1069. These are a little bit higher capacity, so you might have a bank of labs that you're feeding or gang showers for the 1069 application. And then last but not least, you have this hot water purge type feature where if you do have a Legionella outbreak, hemorrhage, you can do a high temperature sanitization. Depending on a digital valve, that's a common feature. And then you want to flush all the way up to the fixture. So this lever here takes that element out of the way, so you can forces all the hot water up to the fixture, or not forces that, you flush it. So that's kind of some of the things with mixing valves. With balancing valves, this is a standard circuit setter that you see here. And really, in essence, water takes the path of least resistance. So when we have this hot water recirc system, we want to deliver enough flow to overcome the heat loss, right? So the further we get away, the more flow we have. So this is a fictitious values I put in here, but my mechanical room is over on the left-hand side of my screen. And if you look, riser 1 just needs 1 gallon a minute, right? With that flow, you have 2 feet ahead. If you look over here, riser 3, hey, double the 2 more gallons a minute. And then the further I get away, you can see the flow go up. And with the increase in flow, there's an increase in pressure drop. So that's, again, fictitious, just for this example only. Now, if I don't balance this, what happens is most of the flow is going to be going here to that riser 1, where it's not needed. And then as I come down here to riser 4, it's going to get very little flow, and that could be a stagnant condition. So my occupants aren't getting hot water quickly, or even worse, it could be a Legionella outbreak, or that could be one of those things. So these balancing valves, really, I look at the riser with the highest head loss, and I'm going to put a balancing valve in there, mostly open. And the head loss of this balancing valve is about 3 feet ahead. So my governing head loss is now 8 feet ahead. So now on all these other risers, I'm adding enough head loss with the balancing valve that gives me 8 feet ahead at the specific flow rate I'm needed. So if I look at this, riser 3, I need 4 feet ahead to be added. So I come over here, hey, this balancing valve, I need 4 feet ahead. What valve position do I have to be in to do that to get this flow rate? You can kind of see. So again, that's the iterative process. It's by all means these are pressure dependent. So if I change one, they all change. And that's one of the things. So they're economical, but again, I think setting those up on a job site can take some time. So let's look at some of our alternative technologies that we have to work with here. First thing, that we look at, this shows actually a large hotel and really with a digital mixing valve. The nice thing about these valves is the range of flow they can handle from high to low. So the beautiful thing about this, and I showed you a high-low, a bunch of mixing valves on a rack. The great thing about these valves is the fact that they themselves can handle that wide range from peak demand down to very low flow and still have very tight temperature control. So that's one of the benefits of them. If you look at this, some of the challenges that we went through and asked some facilities, some of the things they ran into, and you'll see that this gets addressed beautifully with a digital valve. So if I look over here, it's basically temperature control, right? So if you think about that, those mechanical valves I looked at, anything over 40 gallons a minute has plus or minus 7 degree temperature control. So that's one of those things, depending on where that swing is, that can be very challenging, right, for a facility depending on who they are. If you have inconsistent temperatures starting in the mechanical room, it's going to be inconsistent throughout the building. Remember I said if you didn't have the balancing valve set around the valve, like that flow around there, you can have creep because hot water can get passed through the valve, so then you have really hot water when you turn that on. And then I have no access or visibility of what's going on in my building. So those are some of the challenges that they have. If you look at this, like what are some things that are important to monitor and adjust? And it kind of goes without saying, obviously, temperature at the outlet, but all temperatures around the valve, being able to see that is hugely important. And then the other thing is things at and around the valve that make those temperatures tick, right, that I need. So i.e. flow. So, hey, what's going on with the pressures around my valve? And then what's going on with the pumps? If you start looking at that stuff or being able to see that, that's very valuable, especially from afar or at the valve. So if I have this digital stuff, guys, what other stuff do I want? Obviously, alerts and notifications that are prioritized. And then, data and trends, being able to see that over time, that really helps me figure out if there's something wrong, one, with my valve or my system and where in my system, right? So we'll take a look at that here shortly. So that's really nice. Again, these digital valves are fantastic because they help resolve all these issues. So I'll take a look here. If you're going to specify one of these valves, here's some things that I would just mention in your spec. I think ASSC 1017, obviously that's the standard that you're referencing already with these mechanical valves. But ultimately, the tighter temperature control, that's a huge advantage, plus or minus 2. 1, for energy savings, and 2, the safety of the occupants. one from a scalding perspective and even from a Legionella risk mitigation perspective. The other nice thing about this is like there's typically BAS communication protocols on board. So depending on what you have on your project, that would be something that you could look at. And then I think ultimately there's a high temperature sanitization functionality and feature. That's really nice. Heaven forbid there's an outbreak, Legionella. That's one of those things that I could use to help mitigate that. So I'm going to come over here. This is one of the things. Now remember I said, hey, what do we want to see or monitor? And this really kind of shows you in one spot all the temperatures, right? So here's my set here. Here's my set point. And here's my outlet. You notice the green circle? That just shows, and you can look across the mechanical room not be able to see, like you get your cheaters like Dave does. But you can see that green circle is, hey, it's within temperature. If it's blue, it's, plus or minus 3 versus, hey, if it's orange, it's above my set point. The nice thing here is you also see your hot and cold inlet and then your recirc temperatures, right? So seeing that temperature around there is huge. And then what's my valve position from hot to cold? So 30% is basically 32% hot. The rest of that's cold or recirc. If I look over here, you have other information as well. It's touchscreen, so you can swipe this. You can see pressures around the valve. Again, that's hugely useful. And then even flow data if that's something that you have on this tied into this, which is easy to do. So that's really valuable. So that's one of the technologies that again some people were asking for. What do I want to see? You could see that there. The other cool thing is, remember I went through that iterations of balancing with more of a traditional valve. Now you have valves with actual flow meters on them. And so the cool thing about this, I showed this is, again, fictitious and some flows that are required. But this is my reference valve up here. So I start my furthest, again, if you can imagine this, I have balancing on my risers and branches. I have multiple of these. But I could set this in, and as I turn the bezel here, you can see the impact on flow to that. So instead of looking at the chart and then trying to figure that out, it's like, I know I need 3 gallons of recirc flow up here. You can dial this, and that black needle will just kind of take you to where you have to go. Okay. Then I can go down to my next floor and then dial that in to say 2 gallons a minute. And then my last floor down to 1 gallon a minute. So these are pressure dependent, but the nice thing is let's say I have a valve here on my riser. I call that my compensating valve. If you adjust that, it shifts all of these valves at the same time to flow across all of them. So it's kind of nice, but it's a nice indicator to show, hey, this is my flow I designed for, and this is what I can see. The other thing to monitor that, there's some other technology, these wireless sensors that tie into a cellular gateway, give you a little bit of flexibility. It's like, hey, I want to monitor that return temperature. So, I want to make sure it's at or above, 122. If it drops below that, tell me or make me aware of that. So those are some of the other technologies that I find is really useful. You can see your flow rates, for example, but by all means, if my temperatures start dropping, there may be an indication that, hey, I have a crossflow issue, for example. So that could be useful too. So I think ultimately looking at some of the tools to diagnose if we have these issues is kind of my next topic here, and I'll talk to you about this. So now that we have these digital valves, for example, we have sensors, how can we find out if we do have an issue with here? So, and I'll look at this. So let's look at what's available to us. And if you think about this outside the building management system, now there's the availability of web tools or apps, right? And the nice thing about that is if you think about, remember that screen I showed you, like, oh, let's see the pressures and temperatures, one screen here, flip the screen, you see everything. We then have the ability to look at that all in one screen. So a snapshot, oops, sorry, I didn't mean to do that. I'm just using my mouse. I can't use my hands. But anyways, you can kind of see here the set point, the outlet temperature, and all the information associated with this. The other nice thing that we could do is we can kind of take a look and have historical data to look at as well. So if you look at this, you have the ability to look anywhere from 8 hours all the way out to 12 months, a year. If you notice down here, there's charts for temperature, pressure, flow, all this information. You have the ability to kind of look and turn on and off, these different temperatures and trends, just to kind of see that over a time period. So it's really useful. Even if you want to zoom in on an event, you can do that as well. So it's really nice. Okay, hey, is my system operating? Oh, no, it's not. Well, when did that happen? And it's very easy to see that right here. The other place, and again, if you think about this, there's this event log as well, and these get time stamped as far as, hey, what's the issue, what's the criticality of it, and when was it resolved. So that's really nice as well. So if you wanted to zoom in, hey, is something happening the same time every day, or what time of day is it happening? That's pretty useful information. Here's a situation I'll tell you guys a little bit about. This is actually a project I dealt with. This was a project in it was the condominium, this mechanical room. They were upgrading it, and it was a mess. Everything about it was not good, to include the mixing valve. Some piping had to get changed in there, and we, again, started with, hey, you gotta have some good piping, right? And we looked at it, and we made a couple adjustments. And 4 days later, I got a call, and the gentleman was like, hey, look, I have no hot water. It's a high-end condo. It's Friday afternoon, and I just touched that mixing valve, so of course it was my fault, right? And this is the event right here. You can see it. You see the hot water line, and that just drops, and then the mixing valve just opens wide open. So I just like, hey, look, it's not a mixing valve problem. You got a boiler problem there. So that was one of those things that was really useful. To my gosh, 2 hours away from the project, and we started talking about, and then he knew what to go do or look at when he got there, right? So that was helpful. Here's another scenario I'll show you guys, and this is kind of interesting. And remember how I said that orange circle? It shows you when you're above the set point, right? So I had this set at 120, and this outlet temperature is 131, right? And I see a lot of people send me screenshots like this, and it's pretty common occurrence, and like something's not working. And if you look over here, the hot inlet looks right, but notice the cold is, well above the set point as well as the recirc temp. And so, the common question is like, you have a hot water recirc loop someplace in there. So if here's an example of the piping. This is set 120, it comes back 120, but you notice over here, there's another pump. So I got this 140 loop that's going to feed in the kitchen or laundry, let's say, and it's tied in before that crossover. You see that? And so that's one of those things that's, unintended, obviously, but it's one of those things like this is really useful in helping you dial in where to look. And I just, hey, do you got a hot water loop? Yeah, how do you know that? Where's it tied in? So we just got to shift that down. So that's just one of those things that I think is really valuable. The other place that you might see cross flow, and I went through, standard point-of-use mixing valves. All of those, per the standard, ASSC 1070, have, screens and checks on them, right? And that's great because, hot and cold come into any mixing valve, and you want to make sure it doesn't go from one way to the other. Now, what happens is, in the situation, you might have a building with, hundreds of these. If one of those, the check valve gets fouled, for example, that's a perfect place for hot to go into cold or cold to go into hot. Finding that is, you'll pull your hair out. And then ultimately, it's very time consuming. A lot of times, in talking to facility guys, what they'll do is they understand that the problem's somewhere in here. They just change all the valves out. Not very sustainable, right? And throw all the other ones out. So having said that, having some sort of cross-flow indicator becomes incredibly valuable to understand where that issue is. And if you look over here, these indicators can kind of show you the combinations that you might see in here. So for example, pink and blue, hey, it's working great. Blue and blue, it might be just there's no flow, or cold is going into hot. You might have pink and pink, so hot's going into the cold. And then by all means, blue and pink, oops, I crossed something. So that's a really nice indicator, just understanding where that problem is. Again, you could see it on the valve downstream, maybe, right? That mixing valve, master mixing valve. But so anyways, that's kind of one of those things that's kind of interesting. So here's kind of a narration. This is really nice to show how the valve is working or is going to work. First one is just going to show us normal operation, right? So hot and cold comes in here. It passes through the screens and checks, and then there's that paraffin wax element that is just mixing the temperature. Set, let's just say 105 degrees Fahrenheit, right? So next, we're going to kind of go into a cold cross flow event next. We'll kind of see how that looks in this animation. And so hot and cold coming in, but all of a sudden, that check gets fouled, and then basically we're having cold water dump into the hot. And so that's going to be impacting all the valves downstream of it. So if you notice here, the nice thing about this is instead of throwing out the valve, remember I mentioned that, we can take the cartridge out where it screens and checks and get it replaced. So now that we see where the problem is, we can pop a new one in, and that's that simple. Flip side of this, it might be a hot cross flow. And it's just the opposite of what we saw last time. So we see where this problem is. Boy, they're having a whole lot of problems at this lab, aren't they? I think this is Friday the 13th lab, right? So anyways, we'll change out that cartridge pretty quickly, and then pop the pin back in, and then just get it running. And then last but not least is, by all means, they're strainers. And so let's say you have that, instead of tossing out the valve. And again, some of these valves, one of the ones I looked at early in the presentation, people would try to take screens out or repair them in the field, and it was just one of those things. It was quite challenging and time consuming. So hence, that's pretty much why they would just throw them out and put another valve in. So you can kind of see that. So anyways, that kind of just gives you an idea or animation of how that's going. I'm going to flip the screens here. I just want to show you, you just saw 4 times that the cartridge got removed and put in. The cool thing is, again, the cartridge includes checks and strainers. So here's the strainers, on the opposite side is checks. The cool thing about this is the cartridge that it comes in is actually a little bit of a tool. It helps with the assembly. So it lines up the cartridge, and it just gets pushed in for that replacement. So that's kind of a nice little, it's a nice little add-on. I call it the puller inner and putter inner, puller outer and putter inner of this thing. So it's really a nice little tool there. Let me go into this real quick. I think I'm going to go just a couple more minutes and turn it over to Zach here. I want to just mention some of the advantages with that online tool that I was showing you and some of the information that you can get from it. Other than just seeing information, clearly I show you one instance where there is some diagnosing some of the issues. But I think ultimately, especially COVID had started, I see this all the time. I mean, everyone's challenged to find, knowledgeable people. So I run into this in school districts. You might have, for example, 3 plumbers, dealing with 100 buildings. And so that custodial staff is making checks for them. Some do it differently than others. But when you have some of this information at your fingertips and getting alerted to it or seeing it from afar, it makes it far more easier to oh, look, my hot water inlet is low. I should go look at this. So that's one of the things that's nice, is because now you can be literally in 100 places at once if need be. And this example just kind of shows that. This is, a campus setting where, again, everything from the classrooms, cafeteria, and dorms all have that ability to be connected and see the information, hot water in and around the valve. And if there's any issues, again, you can set that on the controller. Hey, I want to be alerted in these scenarios. So that's kind of one of those things about it. Another advantage with this is the online calculators kind of show some of the energy savings for that +or-2 versus +or-7. And there's some other features in there. Again, if you're not dealing with risk management scenarios and you want to set back temperatures where the occupancy is allows for that, i.e. a school, there's some savings there as well. Normally, the one thing I always talk to folks about is, these digital valves, the maintenance on them is super simple, relatively speaking, to a mechanical valve, and the energy savings with that. Between those two things, the payback on these is quite quick. Less than a year is what I mentioned to folks. So that's one of those things I just want to point out with this. So again, this is the objectives in the summary. I'm going to stop right now, and I'm going to turn it over to Zach, and I'm going to stop sharing and let Zach take over here and do some presenting.
Perfect. Thank you very much. And I did see at least a couple of questions come in along the way there. I guess one kind of general comment before we get too far into the spec tool side here. I personally was very surprised to see the applications that you were highlighting. When I hear Legionnaires in the early part of the presentation, I always think like, hospitals, healthcare facilities, long-term care, like those are the ones that come to my mind. But, hearing the breakdown about hospitality, like the hotels and the large towers, it makes a lot of sense once you explain it that way. I did see another question come in on, well, they're asking whether or not the presentation is being recorded. How do we find access to this in the future? Which I guess must mean that you covered the topic pretty well there, Dave. People are hoping to come back and see your work again. So I appreciate that. I'll show you that now.
Well,
It's not going to be
thank you so
live
much.
currently, but if you go to atspec.com and go to the Architects and Engineers tab here, and then down to the Learning Hub, you'll see the webinar recordings. And from the webinar recordings, you have all of our previously recorded sessions. You can see the variety of topics that we've covered recently, from barrier-free deep dives into the washroom space, an overview of the code challenges around pipe, right to pump sizing, and even a new one for the architectural side focused on bidet seats. So from very deep mechanical heavy products to some of the more new age products that are starting to become popular. If this is your first time at an ATS university, thank you very much for joining us. Hopefully you found it valuable. We host these on a near weekly basis, I would say, usually about 3 a month, where we take these deep dives into the products that the manufacturers on our tools provide to the industry. If it's your first time at ATS University, it's probably your first time hearing or seeing ATS. We are essentially a software company these days. We focus on providing tools to the design community, whether that be interior designer and architect or design build contractor, plumbing engineer, anything like that. We try to provide you tools for the manufacturers that pay for our service. So the tools are all free for the design community. They're paid for by the manufacturers with the goal of helping you size, select, and actually configure the products in a streamlined and easy manner. The goal is always to improve efficiency and fit into your current workflows. We're not looking to replace any other systems you might have. I know there's other spec tools out there, and it's kind of natural to say compare ATS to that. But really, we tie directly into those other spec tools. We have formats that tie directly into those. We are more trying to fit into your research phase than we are trying to control your, call it the spec phase. Of course, our deliverables are, various written specs, schedules in Excel, configured PDF specs, or configured PDF selections in submittal format. And again, all this is going to be within your free ATS account. You can see I'm logged in as my demo engineer up here in the top right. You are going, we're looking at the ATS spec tool here, which has about 40 different manufacturers. And if you go to Spec Hub, you'll find a very similar format, and your login will actually work across both different tools. The difference would be the Watts Spec Hub is where you are looking, maybe you're looking for Watts specific product. Really you're only using the spec tool or softwares for the Watts product. Watts Spec Hub is a perfect fit for that. If you're looking for a larger house of brands, you can use the larger ATS spec tool. For today, I'm just going to probably live on the Spec Hub because it's a little bit more dialed into what we were focused on. But of course, if you want more info on the spec tool overall, happy to provide that as well. The same functionality is going to exist in both. We have our kind of our dashboard, our widget here on the left, which shows the product catalog, our quick actions area, where we can access our projects, masters, templates, and quick specs. If you're unfamiliar, essentially we are going to create a folder. The folders have different levels of detail to them, and then we are going to basically add things to that folder that we then download. A quick spec is kind of exactly as it sounds, the fastest, quickest way to make a selection. A project would be the next step up. Easiest way to explain it, a quick spec is going to have no application tied to it, no tender date tied to it, whereas a project is going to have a location, the application, and when it's going to market. It's important for you to add these on your projects because it helps us keep your projects up to date. Quick spec is going to be kind of static as soon as you make it, whereas a project in a master is going to be kept up to date for as long as it's current. So if we set this to October 2026, then we will keep any of our selections up to date until that time. If we select it for California or Texas or New York or Florida or any other state in between that has local codes and standards that are different than, say, ADA or have different, say, efficiency standards, then those will be tied into our what we call our rule engine as well. So our rule engine will make sure that your project is built to the code that you're appropriately following. And that's similar for applications where, say, you select a hospitality or hotel, you are going to get certain rule engines that recommend appropriate product for that application. And the last folder I mentioned was masters. This is essentially your repeat work. I'm going to show you why we create masters shortly. Essentially, it helps us keep it up to date longer, but it also provides a lot of efficiency for you and your team. If you're the team lead, you might want to set the masters, set all your standards, set your approved products, and then your team can all work off of that together on the system. So let's do that's a bit of a longer intro here than I typically go into. I've got a pre-made project here. We've got a Watts mixing webinar project. It's empty. How do we add product? We've got two different ways. We can go what we call the old way, and we use our tiles. So we hit that add product button. We've got all these different products here. We can search for mixing valves. We could search for balancing valves. We could search for leak detection or anything in between. And then we can start making our selection. So if we go into a mixing valve, we could, search for that new one with the cross connection features. We could search for mixing. We could use any of our filters here on the left to filter down by, say, digital mixing. We see all the various options that Dave covered. We can go through, make our selection. Maybe we need a 1-inch line size. Or if we're doing some of the pre-piped, a little bit more heavy duty, we might have some additional options where we want, say, strainers. We have a 3-inch line size, single valve. We'll do an 1.5-inch return. And every time we are making one of these selections, we are updating our model name and number and getting a list price if need be. So if we, in addition to that, we have the manufacturer's spec sheet tied directly into this. So if you are unsure about any of the options or want to review any of those, graphs or curves that maybe come with a product selection, all the manufacturer's cut sheets are going to be embedded in the system as well. So you can help make the right decision and, get exactly what you need. And then you can configure the selection to get the exact model name and number that you need on the system. We'll hit add product. And if there's anything else that would be required to go with this product, then we would bring it up here in the fixture chain. For example, a backflow might need a strainer, or the leak detection might be multiple steps. So we build a fixture chain if need be, or we just do a simple single selection here. We can call this TMV. You can call it whatever you want to call it. And then you could hit the download spec button here in the bottom and download this in our submittals, schedules in Excel, 3 different types of written specs, the manufacturer cut sheets, the Revit files for everything in your project. And if you are using like a spec link or a 3-part spec, master spec format, then the CSIA 3-part spec will tie right into that as well. But as much as that's, simple and easy, that's also what we call kind of the slow and old way of doing it. If you are a team lead and you want to preset your masters for your team, this is one of the best new features that we've come up with. So you can have your masters as well as our ATS templates here that allow you to very simply open up your approved products. We can go to our mechanical valves here. and simply drag and drop over. So you as the team lead could kind of set your preferences for the application. Your team can all come in and say, okay, I know that this is the backflow that my team lead approves, and simply drag and drop it into the files to build up everything else that we need. Let's say we need to add a couple of floor drains and a funnel floor drain. Again, we'll just drag and drop over. Very simple, very quick and easy to use. We can, of course, adjust and edit any of this after the fact. If we see, okay, this is actually the wrong line size, we want to, get down to a 1-inch line size, we can make that change very simply and easily. And then, of course, you could download the entire thing right here in all those different formats again. And I'll pull those up. I've already pre-downloaded. So the schedule in Excel comes in like this. Everything is open and editable, so you could simply highlight, copy, and paste and pop it directly onto your drawings or CAD or anything that you need. The CSI 3-part spec, you're probably pretty familiar with this. Most of the engineers in the States are using this type of format where you've got your appropriate headers and then kind of a bulleted out list of the key features and then your basis of design. We can input base of design and alternates into this selection now. So again, your master can be preset with exactly what you approve. And then all of your team can be working off the same verified information. And then the other mixing valve selection, or the other word spec that we provide, this is our long spec format. We have a short spec format as well if you prefer a less detailed version. And then the submittal. And again, the key part is every single option that we're selecting is being detailed in our output verbiage, is being detailed in our configured model name and number. It's being kept up to date as the manufacturer, is involved in keeping this data up to date. So if Watts goes and changes this model number 3 months from now, 4 months from now, a year and a half from now, your master is going to be kept up to date and you're going to be working off of verified information. This is our manufacturer spec sheet format as well. Again, all the detail you could possibly need. And then, of course, we covered it before, but the Revit files for the entire thing can be downloaded just by a check of a box. And again, this is going to work back and forth on the spec tool. So if I go into my projects now, my Watts Mixing webinar, and refresh it, the same products are available here. And again, the big difference between the two, the same mixing valve is available. The same drains and everything are available. The only difference is the ATS spec tool is going to have, say, your water heaters, your sump pumps, if you're on the fixture selection side, all of those as well. If you're looking for like Bradley multi-labs or anything, that'll all be here as well. So that's kind of the key difference here. One is your Watt specific tool. One is available with additional brands and additional manufacturers. The biggest part is always getting started. So if this is your first time seeing, Spec Hub or the ATS spec tool, it's going to be a big help to you, but it can be a little tedious to get your master set up for the first time. That's why myself and Vishnu and Melanie and Mo and Andre and all of our speakers exist. We're here to help you get set up and get started. We'll train you on the system. We'll get your masters built on the system so that you and your team can all access them. And we'll also set up great trainings like today. If you want something like this specifically for your firm, we're happy to connect with all of our manufacturers, set up this great detailed Ask VCU specifically for your firm if needed. And we also host a number of these ATS webinars, like I said, almost weekly. So as I mentioned at the top, this is going to be recorded. We'll have your certificates out early next week. Look out for a contact from my colleague Natalia. She organizes all the follow-up on this. And if you want help getting your masters updated with digital mixing, with any of the additional information that we covered today from balancing valves or anything like that, feel free to reach out. We'll get in contact and loop David in to make sure that we answer all your questions, help you update your masters, and help you keep working with accurate information. Thank you very much for your time today, David. That was great. I always love learning more.
Thanks for having me, Zach. And appreciate everyone else's time here.
And
So much.
appreciate everyone jumping on the call. Bye for now, all. Have a great one.
Take care, guys.